Hey, Precalc, we got some more trig graphing coming your way today. Today is kind of a big day. We're going to put all the pieces together that we learned kind of about individually yesterday, and we're going to be focusing on sketching one cycle of the graph. That is my name, actually, sketch one cycle. So we know that sine and cosine curves kind of continue their patterns forever and ever and ever and ever. So in order to accurately sketch the graph, we're just going to consider what one cycle of the curve would look like, and we'll sketch it over that interval. So you'll see what I mean by that in just a moment. To get started for something like number one, what we're going to do is when you have a frequency on the inside and a phase shift, like the plus pi over 3, it's really important that you factor out this number 2. That frequency is kind of a GCF because we can't identify the phase shift, how far left or right this has gone, until the coefficient of x is a 1. So I'm going to translate this equation to be 3 cosine. If I take the 2 out, we get x plus. Now remember that taking a 2 out is like dividing this by 2 or like multiplying it by a half. So that becomes a pi over 6 on the inside with a minus 2. Now I'll tell you that in this form, we can clearly identify what the phase shift is, that left or right shift. And in fact, what we're going to do right now is below, we have a lot of things that we have to list before we can even get started. First and foremost, the amplitude is one of the big changes that happens. It's the number that's out front. So the amplitude is 3. The frequency is the number 2 that I factored out. That's that coefficient of x in the original equation. And what that gives us is once I get the frequency, the next thing I typically list is the period. Remember, the period is 2 pi divided by the frequency. So pi, that's how often you're going to see one cycle of this cosine curve sketched. All right, let's talk about some of the other key changes that happen. There is a phase shift. So PS is going to be my abbreviation for phase shift. That's the left or right. Because it's a plus on the inside, we're going to shift to the left, and it's going to go to the left pi over 6. It looked initially like it was pi over 3, but again, factoring out that frequency is what tells me it's actually going to the left pi over 6, which I will list as negative pi over 6. All right, then we have a vertical shift. We are moving up and down. It's going to actually move down 2. So there's a lot of good info that we get just from the equation in terms of some of the transformations that are happening. The next thing I want to talk about is what's the range of this graph? So when I go to sketch one cycle, what's the highest point that I'll reach? What's the lowest point that I'll reach for y values? And what I like to do is I start with the range of the parent function. -1 to 1 is good old cosine x. And then there's two things that would affect the range, the y values. It happens to be anything vertical. And we know that there's vertical stretching that happens. We also know that there's vertical shifting. And we want to make sure we apply that in the right order. The vertical stretch is the amplitude. So you're always going to do the amplitude part next. That's going to multiply the ends of the range by 3. So we're now going to get a range of -3 to 3. All right, and then the last thing we have to do is account for the vertical shift. The vertical shift takes this whole thing and moves it down 2 units. So we're going to take each end of the range and subtract 2 to wind up getting -5 to 1. Okay, this is the final range of y values that we're going to plot when we make our one cycle in a minute. Okay, so what does one cycle of this graph look like? Well, we know that good old cosine x looks like this. So I think it's nice to make a quick sketch of the parent. This way I know in the end, this is what I'm going to see, but it's going to be shifted, somewhere else on the coordinate axes. I'm going to ask you to identify 3 more things. I'm going to ask you to identify a start point, an end point, and then a midpoint. So in other words, here's the start, here's the end, here's the middle. Whole list of information. Well, here's what's happening with the start. The start is going to be according to the phase shift, because we're taking that graph, we're shifting it to the left or to the right. Since we're going to the left pi over 6, the x value of where I start is going to be over -pi over 6. Now, what's the y value of the start going to be? Look at where this starts. It's at the highest point in the range. What's the highest point in our range? Highest point is at 1. So the start point is at -pi over 6. Let's talk about how to find the end point. The easiest thing to do for the end point to start is figure out that it's at the highest point again. So the y value is still 1. But to figure out how long it took me to get to that end point, remember that that's the concept of what's the period? Okay, how long does it take to complete one cycle? Well, the period we identified earlier is pi. So to get to the endpoint, you're going to take the start and add on pi. It's not that I'm just adding it on to 0. You have to go from where you're starting and add on that period of pi. Now, in order to add these two things together, you do need a common denominator. So I'm going to sneak a 6 pi over 6 in there. That's going to total then 5 pi over 6. Okay, so if I add on pi to this, one cycle of the graph, one period, that's where we're going to end. And then last but not least, where's that midpoint going to occur? Where's this point going to be located? Well, first and foremost, let's talk about what's midway between -1 and 5. If I think on a number line, midway between -1 and 5, that's at +2. And I realize 2 pi over 6 reduces, but to be honest, I think it's actually easier to leave it like that. Let's talk about where the y value is when I'm at the middle of the graph. The y value should be at the lowest point in the range, which in our example is at -5. These are 3 very specific points that we can plot on the graph, and now we're actually ready with all of this information to go ahead and start making a sketch. So let's draw some axes. We're only shifting this graph, by the way, to the left pi over 6. That's not very far. So you can actually push your y-axis pretty far over to the left side. You don't need a ton of space over here, just a little bit. Now, in terms of where the x-axis should go, we need a lot more negative y values than we do positive. So I'm going to kind of push my x-axis up a little bit because I don't need a ton of positive y values. Now, the next important thing to decide is what scale do I want to use on the x and the y axes. The y-axis scale is usually a little bit easier. I'm going to make a scale going up by 1s on the y-axis. So -5 would be right here, and +1 would be here. Could I have probably fit in a scale going by 2s? Maybe. But I think it's easier just for this example to make a scale going up by 1. All right, the next important thing to decide is let's decide on a scale for the x-axis. You probably have a few things that would work, but I don't like my graphs to be too crunched and squished together, even though that would technically be okay. I'm going to make a scale of every 2 spaces on the x-axis to be another pi over 6. Okay, so when I go 2 spaces this way, I'm going to label this as -pi over 6. And when I go 2 spaces to the right of 0, that would be 1 pi over 6. So then this would be 2 pi over 6. I'm going to label that because that's where the midpoint is, by the way. Go another 2 spaces, there's 3 pi over 6, 4 pi over 6, and the last spot I need is 5 pi over 6 because that's where the endpoint is. Could I have probably even stretched this out to make every 3 spaces pi over 6? Yeah, I think it would have fit just fine there as well. But I'm pleased with where I'm at with my scale. I'm now ready to start plotting some points. I know that to start, it's at -pi over 6, 1. The end is at 5 pi over 6, 1. And then in the middle, 2 pi over 6, we're down here at -5. If you want to graph the wrap line, that is up to you. But the wrap line, remember, we shifted this down 2 units. Okay, so y equals -2 is going to be the line that this graph wraps around. So midway in between the start and the end, it's got to hit the wrap line. And then midway in between the middle and the end, it's got to wind up hitting the wrap line again. So is there a nice halfway point here? 1, 2, 3, 4, 5, 6. Yeah, I guess 3 away. So like maybe right here, it would cross. And then 1, 2, 3, it would cross here again. If you don't have those in-between points on the wrap line, that's fine. Look how nice that is. Wow. That is one completed cycle of this graph right here, which looks pretty complicated to start. But if you can break it down into all of these key components, this is the critical info I need you to identify when making one complete sketch. Okay. I'm going to go a little bit faster through the next example now that we've seen the first one. Okay, if you need to slow things down, of course, you'll know how to do that. But let's jump to the next page. On page 27 of the packet, we're looking at y equals -4, sine of 3x plus pi over 4. Okay. Very first thing you have to do, because I started it this way in the last one, is factor out this frequency. So we get y equals -4 sine. If I take out the 3, we now get x plus pi over 12. Okay. So taking out that frequency, now I can clearly see that the phase shift is to the left, and that's pi over 12. Okay. So let's start identifying some of the same info that I listed earlier. The amplitude is not -4, it's actually +4. But I think it's worthy of making a note here that the negative out front means to reflect it over the x-axis. We can't forget that part of it. In fact, when you sketch the parent of this sine graph, I want you to sketch it as an upside down sine graph. Okay. So here's what an upside down sine curve would look like. And because we're reflecting it over the x-axis with that negative out front, that's what I'm going to try and model the rest of my points from. All right, the frequency I factored out was 3, which tells me that the period, which is probably even a little bit more important, is 2 pi over 3. That's how often we see one cycle. We're going to use that information later. The phase shift is we're going to the left, pi over 12, so negative pi over 12. The vertical shift for this one is actually none. There's no plus or minus after the parentheses, so there's no up or down shift we have. Okay. Next, we have to think about what the range is then. So the range for the parent, you're always going to start -1 to 1. That's what it is for good old sine x. The two things that affect the range are the amplitude, which is multiplying this by 4. And then if there was a vertical shift, that would affect the range as well. There is no vertical shift. So this is the final range of y values, -4 to 4. Okay, we're ready to move over to start points, end points, and midpoints. Okay, start, end, and middle. Let's talk about the start point. So the start point is going to be that we shifted to the left pi over 12. So we're always starting at that phase shift. And then what do we know about the start, in fact, the middle and the end of a sine curve? The start, middle, and end are right on the wrap line. They're right in between the ends of the range. Because there was no vertical shift here, the middle of this range is still 0. So it will follow that the start point is actually going to be at negative pi over 12, comma 0. So where's this end point going to be? Well, still at a y value of 0. But how do I get to the end? I'm going to take negative pi over 12 and add on the period, 2 pi over 3. Okay, that's how long it takes one cycle to complete. 2 pi over 3 with a common denominator is really 8 pi over 12. I multiply by 4 on top bottom, so that's a total of 7 pi over 12 when I add those up. There's the end. And then finally, midway in between -1 and 7 is positive 3 pi over 12. Notice how for a sine curve, the middle y value is the same as the start and end y values. So for sine, these are all going to be the same, those y values. Not necessarily always 0, okay, but that's what we're going to use as a reference point. All right, we're ready to start sketching here. So if I come over, we're not really shifting all that far to the left again. So when I draw my axes, I am going to put my y-axis pretty far over on the left here. The range of -4 to 4 is kind of equally spaced there, right? So you can draw your x-axis as close to the right through the middle as you can. Okay, now we have to think about scales. I am going to just go up by 1 on the y-axis, -4 to 4. And for the x-axis, every 2 spaces seems reasonable to me again to call that, in this case, pi over 12. You know, if you wanted to extend that a little bit further, you could. But if I call this -1 pi over 12, this is +1. This is 2 pi over 12. I'm going to label 3 pi over 12 because that's midway through. 4, 5, 6, and then finally 7 pi over 12. Okay. When I go to make my sketch, the start, the middle, and the end all happen to be right at a y value of 0. If there was some sort of vertical shift, all those points would move up or down and be right on top of the wrap line. Okay. But what does sine do? Sine, if it's a negative, here's why I think sketching this parent is so important to remind myself. If there's a negative out front, it's going to go down to the lowest point in the range first. So in between the start and the middle, which is actually at 1 pi over 12, you're going to be down here at -4. In between 3 and 7, which is at 5, you're going to be up at +4. And if you connect those 5 points, you now have one completed cycle of the sine curve there. Okay. All right, so to kind of wrap things up today, wrap line, wrap things up. So we're going to do maybe just one more example where we get the critical info. Maybe I'll encourage you to make a sketch on your own of this last one. And I'm actually going to skip number 3. We'll try number 3 in class. Let's go right to number 4. The only reason why I want to go through number 4 with you is a couple of reasons. There's a frequency of 1/2, so that's going to look a little weird when I factor that out. And then the whole formatting just looks a little weird because there's that +4 out front. So that plus the 4 that's out front is really the vertical shift piece. I'm going to slide that over to the end just to make it look a little bit more normal. So we get y equals 2 sine. If I factor out 1/2 as the frequency, factoring out 1/2, when I divide this by 1/2, it's like multiplying it by 2. So the tough part about this is dividing this by 1/2. Like I said, it's like multiplying this whole thing by 2. That's why it becomes a 2 pi over 3. I wanted to make sure we set that up correctly. Again, this +4, I'm going to put that at the end because we know that's really the vertical shift. All right, let's go ahead and think about some of the key information here. So here's what you should come up with. Amplitude is 2. It's the number out front. Frequency is 1/2, which makes the period 4 pi. 2 pi divided by 1/2 is 4 pi. The phase shift, we're actually going to the right this time, 2 pi over 3. And the vertical shift, we're going up 4. Okay, so I came up with that info really quickly. You're gonna get to a point in this unit where I hope you can come up with it just as fast as I have. The range, you're always gonna start -1 to 1. You're gonna multiply by the amplitude first, so times 2 would get you -2 to 2. And then last but not least, do the vertical shift, which is add 4. So if I add 4 to both ends, you're gonna now be from 2 to 6. There's the range. Okay, last thing we'll do today is talk about start, middle, and end points. The start point. Well, remember, here's what sine looks like. I'm going to draw a right side up sine curve, by the way. Right? We did upside down sine before because the amplitude had a negative out front. This is normal, good old sine. All right, we're going to the right 2 pi over 3, so that's the start value. How do I figure out this y value? Because I'll tell you, it's not 0 this time. The start, middle, and end are in the middle of the range, right? If this is the lowest and this is the highest, what's midway in between? Well, let's check it out. What's midway in between 2 and 6? For our range, the middle value there is 4. And that makes sense because this whole graph got shifted up 4 units. So these 3 points are going to lie right on that wrap line, y equals 4. Okay, let's talk about the end point. We have to take the start and add on the period of 4 pi. So if I make a common denominator, this would be 2 pi over 3 plus, multiply the top and bottom by 3 here, that's 12 pi over 3. So 2 and 12 is 14 pi over 3, comma 4. Because the end is the same y value as the start. And last but not least, the middle point there. So midway in between 2 and 14, you're finding an average. So you could always add those up and divide by 2. 2 and 14 is 16. Divided by 2 is 8 pi over 3. Middle is still that same y value. Okay. So we found all the key information, and I know that was fast, but see if you can then make a sketch. Could you create a good scale that makes sense here? For your x and your y axes, you have the start, middle, and end points. Hopefully you can get a good point for these max and min values as well. See if you can graph this, and then we'll go back and do number 3 as well tomorrow when we're in class. Okay, so that's it for some trig graphing today. A lot of information, but with some more practice, you'll start to gain some confidence with trig graphing. Have a great rest of your